So picture the universe for a second. If you're like, well, most of us, you're probably imagining this giant dark balloon.
Right, just inflating endlessly.
Exactly. This is massive empty void expanding outward, driven completely blindly by just the brute force of gravity.
And that is pretty much the standard cosmological picture most people are taught. Just a cold mechanical expansion into, an endless empty nothingness.
It feels incredibly lonely, honestly.
Yeah, it really does.
But what if that entire mental image is completely wrong? What if the universe isn't a balloon expanding into a void at all, but rather an unfathomably massive self-organizing computer?
It's a wild shift in perspective.
Right, like a system that is actively running a program, and you sitting there right now listening to this deep dive are literally a crucial piece of its hardware.
It completely inverts how we view reality. I mean, we're moving from a universe that is just a passive container of random objects to a universe that is an active, optimizing engine.
So to understand how you fit into this cosmic hardware, we have to look at a radical new perspective in physics. It's called the Cosmos framework.
Which is just fascinating.
It is. This framework attempts to fundamentally redefine space-time itself. And it's pulling from, theoretical physics, systems theory, mathematical logic.
All the heavy hitters.
Yeah, all the heavy hitters. And the mission for this deep dive is to give you a shortcut to understanding this mind-bending theory, but without getting lost in the dense math.
Which I think we can all appreciate.
Definitely. So to really grasp how the universe transitions from a physical space into a computational entity, we actually have to start before the beginning.
Down in the absolute basement of reality.
The basement, yeah.
Because to understand a computer, you have to understand its fundamental transistors. For the universe, that is what physicists call the Planck scale.
Okay, and how small are we talking?
We're talking about distances of roughly 10 to the power of negative 35 meters.
Wow.
Yeah, it is unimaginably small.
Just to put that in perspective for you, if a single atom was the size of our entire visible universe, the Planck length would be about the size of a regular tree.
That is a great analogy. It really is the absolute limit of smallness.
And in standard textbook physics, this is where the math just, throws its hands up and quits, right?
Pretty much, yeah. Our current theories, general relativity, quantum mechanics, they do completely break down at this scale.
They just stop working.
Right. They generate infinities and logical paradoxes. But in this new framework, this scale isn't a breakdown of the laws of physics. It is the recursion floor.
The recursion floor.
Yes, it's the foundational substrate from which everything else is built.
So it's the bottom turtle holding up the stack.
Exactly, the bottom turtle holding up the entire architecture. And the framework proposes something fascinating here regarding the fundamental modes of reality.
Because normally we think of the universe as having distinct ingredients, right? Like energy and matter, information and pattern.
Spatial geometry, time.
Yeah, and those seem like pretty non-negotiable separate things.
They do, but down at the recursion floor, they are not separate. Those distinct modes are mashed together into a single primordial state.
Which the framework calls the unified mode.
Or simply U. And in this state, there is absolutely no distinction between energy and information.
None at all.
None. There is no spatial geometry. There is no time. The Wheeler-DeWitt equation in quantum gravity actually hints at this beautifully.
Wait, the Wheeler-DeWitt equation, I've definitely heard that name dropped in sci-fi movies, but what is that actually measuring in the real world?
Well, it's an attempt to mathematically combine quantum mechanics with general relativity, so to create an equation for the entire universe.
Okay.
But when physicists finally wrote the equation out, something alarming happened. The variable for time simply dropped out of the math.
It just vanished.
It vanished. The equation suggests that at the most fundamental quantum level of the universe, time does not exist. The universe just is.
I mean, I've definitely been in a few corporate budget meetings where time felt like it completely dropped out of the equation, but
it certainly feels that way.
But it's wild to think that's actually a fundamental property of physics. So if there is no time and no space, what is this unified mode doing?
Nothing. Nothing. Nothing at all. It is pure, unexpressed potential.
So it's like a completely compressed ZIP file.
Ooh, yes.
Like all the data, the entire architecture for everything that will ever exist is in there, packed infinitely tight. But until you double-click and extract it, it doesn't actually do anything.
That analogy holds up perfectly. The unified mode is infinite potential with zero actualization. And if the Planck scale is that ZIP file, then what we call the Big Bang is the ultimate double-click.
My brain is already tingling. Because when we normally think of the Big Bang, we picture a literal explosion, like stuff flying outward through dark space.
Right, fireworks in the void.
Exactly. But if space didn't exist yet, there was no space to fly into.
And that's why the framework completely rejects the explosion in space concept. Instead, it defines the Big Bang as an event of ultimate symmetry breaking.
The shattering of the ZIP file.
A simultaneous shattering at all points. That perfectly balanced, unified mode fractures.
Wow.
And suddenly, energy and matter emerge to provide the physical substance. Patterns and quantum information emerge to provide the logic.
And space-time geometry and structure emerge to provide the spatial relationships, right?
Yes, and time itself begins ticking to sequence the events.
See, I'm stuck on this idea of it breaking, though. Because if the universe just cleanly split from a state of perfect, elegant unity into these distinct modes, shouldn't the result be perfectly, flawlessly balanced?
Well, you'd mathematically expect perfect symmetry. Yes, equal amounts of everything.
But if it's perfectly balanced, doesn't standard physics tell us that matter and antimatter would have been created in perfectly equal amounts?
It does.
And if that happened, wouldn't all the positive and negative energy just immediately crash back into each other?
They would?
Just cancel each other out and leave absolutely nothing behind except a boring, endless bath of photons. Like just light forever. No stars, no planets, no carbon.
That is the exact paradox physicists have wrestled with for decades. The threat of total cosmic annihilation.
Right.
If this symmetry breaking of the Big Bang was flawless, you and I wouldn't be having this conversation. There would be no matter to build microphones or human vocal cords.
Which brings us to arguably the most important number in the universe.
I love that a single number can be the reason anyone is alive to hear this.
Me too. So what is it?
It is the ultimate creative spark. We call it the Baryon asymmetry.
Okay, break that down for me.
So in the absolute fraction of a second after that double click, there was a tiny, almost imperceptible imbalance in the shattering. For every 10 billion particles of antimatter that were created, there were 10 billion and 1 particles of matter.
Oh, wait. Just one extra particle out of 10 billion.
A single solitary extra particle out of 10 billion.
That is insane.
It is. And that tiny fraction, which is roughly 6 times 10 to the negative 10, is the leftover matter that refused to be annihilated.
The cosmic remainder.
Exactly. And that remainder makes up literally everything we can see and touch in the cosmos. Every galaxy, your coffee cup, your dog, your own hands.
Okay, I understand that a perfectly symmetrical photon bath is boring, and we needed that extra matter to exist physically. But earlier, we talked about the universe being a computer.
We did, yes.
How does having a tiny bit of leftover physical matter suddenly give the universe a hard drive? How does a physical particle store a computational state?
Well, it comes down to the requirements of computation itself, axiom 2 of this framework.
Yeah.
For any computation to happen, whether it's on a laptop or in a cosmic vacuum, you must have a persistent, addressable state. You need memory, hardware.
Okay, so why can't light do that?
Photons travel at the speed of light. Because of relativity, from their own perspective, they experience zero time. They cannot hold a state.
Because it's moving too fast to remember anything.
Yes. A universe made only of light is like a computer screen constantly flashing static. Nothing is saved. It's exactly the opposite of memory. But a baryon, a particle of matter like a proton, has mass. It moves slower than light. It anchors time.
So it persists.
Exactly. A hydrogen atom can sit in the void of space for 1 billion years, holding its structural integrity. It is a persistent state. It is a 1 or a 0 that can be recalled and interacted with.
So we really have to throw out the old textbook definition of the cosmic scale factor.
We do.
Usually scientists use that term just as a geometric measure of how physical distance is growing over time.
Yeah.
But in this Cosmos framework, this asymmetry number, the 6 times 10 to the negative 10, is the true cosmic scale factor.
Yes, it dictates the baseline computational capacity of reality itself. It is the optimally tuned value that provides just enough hardware for complex structures to form.
Without being so dense that the whole universe immediately collapses into black holes.
Right, precisely.
So this tiny imbalance is literally the hardware memory of the universe. And if the universe has memory, it implies it's actually running a program.
It does.
It's computing something. But what is it trying to calculate?
Well, the framework states in its third axiom that this universal computational process evolves its parameters to maximize its long-term computational potential.
Okay, maximizing potential.
Yeah, and it represents this potential with the Greek letter phi.
Let me try an analogy here. Standard physics treats gravity like a drain in a sink. It's just this blind indentation in spacetime that inevitably pulls matter down into clumps.
Right, the bowling ball on a trampoline analogy.
Yeah, exactly. But this framework treats gravity more like a compression algorithm. It is intentionally packing data tighter to build more complex structures.
That is a brilliant way to frame it. Gravity isn't a blind force bumping around in the dark. It is a control constraint.
A mechanism.
Yes, an intentional mechanism used by the system to organize itself for deeper computation. Pulling dust into stars isn't an accident. It is the universe building denser, hotter processing nodes.
If the universe is actively optimizing its capacity to process information, that totally changes how we have to look at the mysteries we haven't solved yet.
Like dark matter and dark energy.
Exactly. Those are the perfect examples. In the standard model, dark matter and dark energy are massive, confusing placeholders.
We can't see them, but our math says they make up about 95% of the universe.
They're the invisible elephants in the cosmic room.
They really are. But in a computational framework, they aren't mysterious invisible particles we just haven't found yet. They are systemic requirements of the cosmic computer.
How so?
To understand this, we have to look at the cosmic horizon, the absolute edge of the observable universe.
Okay.
The framework treats this horizon as a two-dimensional boundary surface, an interface screen.
Like a holographic screen. I read a bit about this, the idea that a three-dimensional universe might just be a projection from a two-dimensional boundary.
Yes, the holographic principle.
But how does a 3D universe actually get encoded onto a flat surface?
Think of the security hologram on a credit card.
Okay.
It is a completely flat, two-dimensional piece of foil, but it catches the light in a way that contains all the information needed to project a fully three-dimensional image of a globe or a bird.
That makes sense.
The cosmic horizon works similarly. All the information in our 3D bulk universe is theoretically encoded on the 2D surface of the horizon.
Wow.
But encoding that incomprehensibly vast amount of information requires immense structural support.
And that's where dark matter comes in.
Correct. Dark matter acts as the relational scaffolding. You can't just have data floating freely. You need a geometric structure to hold that holographic encoding together.
So it's the framework.
Exactly. Dark matter provides the architectural webbing that allows galaxies to form without flying apart. It is the structural integrity of the computation.
Okay, what about dark energy then? Because standard astronomy says dark energy is the mysterious force that's ripping the universe apart, right? Accelerating the expansion faster and faster.
Well, instead of a destructive force ripping things apart, dark energy is viewed as the temporal persistence of the system.
Temporal persistence.
Yeah, it's the energy required to keep the cosmic computation running. If the universe stopped expanding, if it collapsed back in on itself in a big crunch, the computation would end.
The computer shuts down.
Right. Dark energy ensures the system keeps exploring new probability spaces. It keeps the clock ticking so the universe can find new configurations to maximize its ability to process information.
That is wildly beautiful. The universe isn't expanding into a cold void. It's unfolding in potential.
It really is.
But I have to ask the ultimate so what question here.
I was waiting for that.
Right, because we were talking about Planck scales, holographic boundary screens, and 14 billion years of data processing.
It's very abstract.
It is. Why does this matter to you, listening right now, who might be sitting in traffic, or folding laundry, or walking the dog? How does this abstract cosmic framework connect to the daily human experience?
It connects through the concept of recursion, axiom 4 of the framework. Substrate-process duality.
Okay, lay that out for us.
The universe builds higher and higher order systems out of its own architecture. Any computational process can itself become the foundation for a more complex process.
So human beings aren't just an accident of biology on a random rock.
No, we are a fractal reflection of the exact same system. We are the universe's original algorithms evolved into a biological form.
That is profound.
Think about how a human operates. Our capacity for sensing taking in the world through our eyes and ears is our informational input. Our capacity for thinking, processing that data, making decisions is our informational processing.
And feeling.
Our capacity for feeling operates as our feedback loop, regulating our relationships and our energy levels.
We are a microcosmos.
We are 7ES systems ourselves.
We run on the exact same input processing feedback architecture as the stars and the cosmic horizon. But the part of this theory that absolutely floored me when reading the sources was how it mapped that original mathematical asymmetry to human emotion.
It is a profound philosophical connection hidden inside the physics.
Yeah. Think back to that tiny imbalance we talked about earlier, that one extra particle of matter out of 10 billion that refused to be
A
annihilated.
creative spark.
Exactly. That tiny fraction of 6 times 10 to the negative 10 that survived the Big Bang and created the hardware of the universe. The framework suggests that this cosmic remainder, that stubborn refusal to go quietly into the dark, is actually experienced in human beings as longing.
The relentless drive to explore.
Yes. That feeling you get when you look up at the night sky, or when you feel the desperate urge to create art, or to finally understand a complex idea, or to connect deeply with another person.
It's palpable.
That longing isn't just a random psychological quirk of evolution. It is the biological, human embodiment of the universe's original asymmetry. It's that initial spark of matter still trying to build something more complex out of itself.
It is the literal mechanism of the universe optimizing its computational potential. When you question the world, when you desire to know more, when you demonstrate the courage to handle complex truths, you are acting as the universe's processing node.
We aren't just living in the universe. We are the universe exploring itself. When you learn something new, when you have an aha moment during this deep dive, you are literally the universe increasing its computational capacity. You are upgrading the software of reality.
You are a sensing, thinking, feeling biological system. The universe is not a passive environment you were dropped into. It is a self-designing system, and you are its living, breathing expression, exploring probability space in collaboration with everyone around you.
I love that so much. It really makes folding laundry feel a little more cosmically significant.
Doesn't it?
Okay, let's take a breath and recap this incredible journey. We started at the absolute bottom floor of reality, the Planck scale, where everything was packed into the ultimate compressed ZIP file with no time and no space.
Which then shattered in the ultimate symmetry-breaking event, splitting into physical energy, information, spatial relationships, and temporal sequence.
But crucially, it fractured with a tiny, perfect imperfection. That 10 billion and one imbalance that saved reality from total annihilation, giving the universe its physical hardware memory.
The cosmic scale factor.
Yes. And from there, we realize that gravity isn't a blind drain. It's a compression algorithm packing data together to optimize the system.
Dark matter is the holographic scaffolding.
Dark energy keeps the processor running. And human curiosity, our deep, stubborn longing, is the universe pushing its own boundaries.
It is an elegant model, but if we look at the logical conclusions of these rules, it leaves us with a rather profound and perhaps dangerous final thought.
Oh, right, because not every system we build as humans actually aligns with these cosmic rules.
Far from it. The framework states that for any system to be viable and survive long-term, it must honor these fundamental processes.
Meaning what, exactly?
It must rely on accurate feedback, it must be decentralized enough to process information efficiently, and it must operate symbiotically with its environment. We call these natural systems. But humans have the unique, terrifying capacity to design unnatural systems.
Like systems that centralize control, ignore feedback loops, and extract resources without optimizing anything. Things like highly extractive economic models or rigid authoritarian power structures.
Or poorly aligned artificial intelligence systems that completely ignore biological realities. The framework refers to this systemic arrogance as the observer-centric fallacy.
We think we're above the rules.
Exactly. We build systems that assume we are separate from the universe's baseline rules. And the lingering question is this. If the universe's ultimate goal is to maximize its computational potential,
Right.
and human beings are the highest order computational substrates the universe has ever produced on this planet,
What happens?
what happens to the cosmic program if we design artificial, unnatural systems that fundamentally violate the physics of computation?
Do we crash the code?
That is the ultimate question. Does our failure to align with these natural laws crash a localized part of the universe's code, leading to systemic civilizational collapse? Or are we, through the sheer friction and pressure of these unnatural systems, pushing our local environment to the absolute brink, forcing the universe's next great symmetry-breaking event?
Wow. That is a lot to chew on. Are we the glitch that gets wiped from the hard drive, or are we the pressure cooker for the next Big Bang?
It's a heavy thought.
It is. I suppose it entirely depends on whether we choose to design our future in alignment with the universe's architecture or in stubborn defiance of it.
I think you're right.
Well, thank you so much for joining us on this deep dive. Tonight, when you step outside and look up at the stars, I hope you don't just see a cold, empty balloon expanding into nothingness.
Look closer.
Yeah. I hope you see the ultimate unfolding computational spark. And remember, you are an essential piece of the hardware. Keep exploring.